All right, so again, we're practicing Lewis dot structure, vsepr, angles, and polarities. So I'm going to do a couple problems here from your worksheet. I am not doing the process because you don't need the process when you're doing vsepr, angle, and polarity. But if you don't know or your Lewis dot structure didn't match mine, go back and do the process because you could get any of these compounds on a process question and not on a vsepr question. Okay, so Br2. No central atom, so just bromine single bonded with bromine. Bromine has 7 valence electrons, 1 gap for 1 bond. Okay, so there's your Lewis dot structure. Your vsepr, 2 points can only make a line, so linear 180 degrees. And its polarity. Okay, even though, since there's no true central atom, we don't have lone pairs. They're completely balanced, no unequal sharing. They're both the same element, they're symmetric all the way around, everything you can think of. They are going to be nonpolar. And since they're nonpolar, they're going to use dispersion forces only for their IMF, or remember that's intermolecular forces. All of these are covalent, so they're all intramolecular forces. Okay, H2SE. Se goes in the center because Se has 6 valence electrons. Hydrogens go around. We need 6 valence electrons on selenium to be done. There's your Lewis dot structure. It's a 2-2, 2 outer atoms, 2 lone pairs. 2-2 is a bent 105 degrees, right off the chart. Okay, and make sure you're using the vsepr chart that is in the unit, because if you use Google, they're going to give you slightly different angles for each one because each guy is slightly different. They're unique, just like everything else. But to get credit in this class, you can't use Google. You got to use our chart. Okay, polarity. They have lone pairs, so they are polar. Any fun bonds? Nope. So they are dipole-dipole for the IMF. This is H2SE. Next guy, CH2F2. Okay, carbon's in the center because he has 4 bonds. I'm just going to magically spread around these guys. Fluorine, I'm going to make sure it has the right valence numbers, and hydrogen and carbon when I'm done. That's our full Lewis dot structure. Now, for year 1, you're going to go with different outer atoms. So you're going to say polar. No fun bonds. Okay, the H isn't bonded to the F, so it's not hydrogen bonding. It's just dipole-dipole. And it's a 4-0 tetrahedral, 109 degrees. pH3, phosphorus trihydride. Phosphorus goes in the center with 3 gaps. Hydrogens go around. Phosphorus has a total of 5 valence electrons, so 1 lone pair. 3 bonds with other atoms and 1 lone pair, 3-1. Trigonal pyramidal. Lone pairs push more, so this guy is 107 degrees as opposed to 109 if he had 4 bonds. He is polar because he has lone pairs. There are no fun bonds, so he is dipole-dipole. SiO2. Okay, silicon goes in the center because he can make 4 bonds. Oxygen on either side. They can take a maximum of 2 bonds. So I'm going to just go ahead and start with 2 bonds on each one because I know silicon wants 4 and oxygen wants 2. How many leftover oxygens? 1, 2, 3, 4, 5, 6. 2, 4, 6, 8. So each oxygen has a double bond and 2 unbonded pairs. Silicon in the center has 2 double bonds. 1 double bond with silicon with the left oxygen, 1 double bond with the right oxygen. This is not a quadruple bond. Bonds are only between the 2 atoms, not the whole structure. Okay, silicon doesn't have any lone pairs, so this is a 4-0 tetrahedral, 109 degrees. Polarity, No lone pairs on silicon. Remember, these are unbonded electrons. Lone pairs are what's on the central atom. Okay, and there are, what am I doing? 2 atoms of oxygen, 0 lone pairs, linear 180 degrees. I guess that was a good thing to point out. You don't count this as 4 because you only look at the electrons. So I need more coffee today. 2, 0, linear 180 degrees. He is nonpolar, no lone pairs, symmetric, and the same outer atoms. So he works on dispersion forces. O2, oxygen with oxygen, no central atoms. So right now, before I even go on, I can write linear and 180 degrees in the answer. And I know that those are the only things they have with linear and same atoms. So I know he's nonpolar dispersion. So I could actually write this all out without drawing the structure. Oxygen wants 2 bonds. And we have 2 unbonded pairs on each side to make 2, 4, 6, 8, 2, 4, 6, 8. Okay.